All right, this is 2005B number 2, and it's about tickets to a concert, and we're given a probability distribution or probability model, which is the discrete probability model for the number of child tickets. You know, the probability that we sell 0 children's tickets is 0.4, that we sell 1 is 0.3, and so forth. This is for a single customer. Again, advice, read all the parts before you do any, and you'll sort of get an idea about what's going on. Part A, straight computational question. Let's find the mean and the standard deviation of this random variable. Okay, remembering that the mean is the expected value. The way we find that is we take each value and we multiply it by its probability, and then we add those products up. It's a weighted average. So the mean is 0 times 0.4 plus 1 times 0.3 plus 2 times 0.2 plus 3 times 0.1, which is equal to 1. Okay? The standard deviation, now this is something we may not remember. What the standard deviation does is it takes each value, and I'll write a formula here. It takes each value, so I'm going to add up the value minus the mean. Actually, it's not x bar, it's mu. And I'm going to square that. Okay, that's the mean difference, and I'm going to weigh that. Okay, and I just screwed it up. So take each value minus the mean squared, and we're going to weigh that by the probability. So it looks like that. Okay, so it's a simple formula, but it's very easy to get mixed up and to put these numbers in the calculator and find the standard deviation or whatever. But each one occurs at a different frequency, so we have to use this formula. So, and by the way, this is wrong because we have to square root. So we're going to do a big square root. We're going to take each value. So the first value is 0 minus the mean, which we got right here, squared. I'm going to multiply that by the probability, plus 1 minus 1 squared times the probability of that, plus 2 minus 1 squared times the probability there, plus 3 minus 1 squared times 0.1. Okay, and so you're like saying, oh God, this is going to be brutal to put in the calculator, whatever. This term goes away because of the 1 minus 1. Okay, this term is 1 squared, so this is just 0.4. This term is 1 squared, so this is 0.2. This term is 2 squared times 0.1. That's 0.4. Okay, square root all that. You add it up. It's the square root of 1, which is 1. Okay, so I didn't even have to use a calculator. Certainly you could, but not necessary. Okay, so I get A, the mean is 1 and the standard deviation is 1. All right, now B is saying that now that we're given the mean and the standard deviation of the number of adult tickets by a single customer, okay, and we're given that the mean of A, so I'm going to do part B here, the mean of A is 2, the standard deviation of A is 1.2. So we have the means and the standard deviation of the children's tickets and the means of the standard deviations of the adult tickets. We're saying that they're independent. We're going to compute the mean of the total number of adult and child tickets. So I can say T is just C plus A. So the mean of T, well, if the mean number of children tickets is 1 and the mean number of adult tickets is 2, then it would make sense that it's just the sum of those. So the mean is 3. Okay, so there's your answer to the mean. The standard deviation, well, what do? We've got 2 random variables. We know the standard deviation of each. We don't add the standard deviations. We add the variances. And we're allowed to do that because it says that the number of child and adult tickets are independent. Okay? So if we're going to find the standard deviation of C plus A, we're going to add the variances and square root. So we're simply going to take 1 squared plus 1.2 squared. And when we do that, we get 1.562. So there's your answer to part B. Okay, you've got the mean and the standard deviation there of the total number. All right, in part C, we're given that children's tickets cost $15 and adult tickets cost $25. Compute the mean and standard deviation of the total amount spent per purchase. Okay, so what we want is, if I call M the amount, we're going to take 15 times the number of children tickets sold plus 25 times the number of adult tickets sold. And we want to find the mean and the standard deviation of that. Okay, so the mean is fairly easy. The mean of M here, of the total money that we get. Well, if we expect to sell one children ticket, they would be 15 times 1, and 2 adult tickets, based on what they told us earlier, 2, 25 times 2, it would make sense that, hey, it's going to cost us $65, or we're going to get $65 on average. The standard deviation, okay, so what we're doing is we're multiplying the number of children tickets by 15. So remember that if we're just looking at the money from the children tickets, that's just, we multiply the standard deviation by 15. This would be 15 times 1. Okay, that's 15. All right. The adult money would be 25 times 1.2. Okay, which is like 30. Is that 30? Yeah, 25. That's 30. Okay, and now we're going to add the variances of this. So to find the total standard deviation, we add the variances. So I've got 15 squared plus 30 squared, which I believe is the square root of 1,125, which if you do the math there, that's $33.54. Okay, so if we look at the question as a whole, very computational. There's really no interpretation involved, and there might be questions like that. It seems like most of them involve a lot of writing and interpretation, but this is how you do it. And if we look at the rubric, just to understand, oh boy, how the heck this is done. Hold on. So looking at the rubric here, we can see that each part is either essentially correct, partially correct, or incorrect. Here's a big thing. Unsupported answers will be scored as incorrect. You conceivably could just type stuff in your calculator to get an answer, but if you don't show how you got it, then you're in trouble. Now, if you get part A wrong, suppose you got the standard deviation wrong, and you incorrectly, or you use it for the rest of the problems B and C, you're not penalized twice. That's important to note. You can use standard notation, but if you use kind of non-standard, then you're going to have to define stuff. And you can see how this is scored right there.